Hello everyone, our group number is 19 and our topic of presentation is speed control of DC machine with AC to DC converter.
Good morning all, my name is Mansi. Today we are going to discuss about the speed control of DC machine using AC to DC converter. AC to DC converter, commonly known as rectifier, are devices that convert alternating current to direct current. Let us start with the simulation process. Three-phase AC source. Drag and drop the three-phase source block from the power system library into your model. Frequency and voltage. Set the voltage parameters such as voltage and frequency. Then design the three-phase rectifier. Use the three-phase rectifier block from the system library. This can be a diode bridge rectifier or an ideal rectifier block. Then configuration rectifier. Then we will set the parameters which we required. Then addition of filtering component like filter circuit and parameter selections to smooth the pulsating DC and an LR and IR rectifier. Use inductor and capacitors from the power system library. Choose appropriate value for the filter component to achieve the desired filtering. Then implement the DC machine model. DC motor. Insert a DC motor block from the power system library. This block should include the parameters of armature resistance, inductance, and field resistance. Then connections of motor. Connect the output of the filter to the DC motor armature terminal. Design and control system includes the voltage regulations and feedback loop. Use the blocks such as PID controller or a more complex control algorithm to regulate the DC voltage. These might be located in the control system toolbox. Implement the feedback loop using a sensor to measure the DC voltage or current to adjust the control signal accordingly. Then control tuning. Tune the parameter of the controller to achieve the desired performance. Then simulate the load conditions. Add a load to the DC motor. This could be a resistive load or the more complex load. It depends on the type of motor. Then variable load. To the test system responsible, you can use a variable load or add disturbance. At the end, the solver setting. Choose an appropriate solver and simulation time for the power electronics and discrete or peak step solver might be appropriate. At the end, the run and simulations of the circuit. Executions. Run the simulation to observe the system behavior. Examine the waveform of the AC voltage, DC voltage, and motor speed and current. Then at the end, optimizations and validation means based on the result, adjust the parameter of the rectifier circuit, filter, and control system to improve the performance. And validations validate the simulation by comparing the result with the theoretical expectations or real world data if available. Thank you.
Myself, Miss Neha Aishwarya, roll number 18. Now I am going to present the topic which is the parameters of the DC converter. Number 1, supply voltage. The speed of the DC motor is directly proportional to the supply voltage measurement. It's done using a voltmeter. Then the armature resistance. It means that the RA. This resistance effect is a voltage drop across to the armature, and hence the speed is measured using a ohmmeter. Then a load torque. The torque required by the load influences motor. Speed load torque is a measure using the torque sensor, the dynamometer. Then field current. In a separately excited for the all compounds motor, the field current or torque voltage motor is affected to the magnetic flux, and thus the speed measurement can be made in the ammeter. The armature inductance. The inductance affects the motor response time and the speed stability. Then the mechanical friction and the inertia. Mechanical conditions like friction and inertia affect now the quickly motor can accelerate to the declarated, and then the friction can be measured indirectly to the power.
My name is Sanika Shankar. My topic name is converter configuration. If a thyristor switch is connected between an AC supply and load, the power flow can be controlled by varying the RMS value of the AC voltage applied to the load. This type of power circuit is known as AC voltage controller. Three-phase AC voltage controller has been used for various circuit configuration. This AC and DC converter feed the DC motor with armature voltage while the field winding is excited with a regulated field current.
My name is Anushka Shirsat, roll number 55. My topic name is simulation result. The first is three-phase bridge, AC to DC and AC to DC converter, DC motor, AENN and PL controller are simulated and connected by MATLAB Simulink under open and closed loop system. As shown in figure A of Appendix A, figure 3 illustrates the waveform of speed response of the DC motor at constant mechanical load torque for open and closed loop condition. It is clear that the PI controller with residual network closed loop environment that the open loop system, the rising time for the spread response with open and closed loop of AC to DC and AC to DC converter at 250 rpm is 0.2, 0.042, 0.325 and 0.035 seconds. The delay time is 0.123, 0.0377 and 0.00717 and 0.00258 seconds are steady state error 25.6 0%, 25.6%, 0% respectively. Hence, the configuration is figure A is more suitable than the figure B shown in figure. The speed response of the DC motor for step change of the reference speed with the constant load torque.